In the previous video, we did a problem where we gave you these results of a transformation, and we want you to find the transformation of 2, 3, -5, and the answer we got was 12, -17, +17. Now, if you notice, based on what we did, and you can look at that last video to see what we did, basically what we did to get the answer was equivalent to the steps that we took was really equivalent to multiplying the matrix times this vector and getting that solution. So I like the way I zoomed out. That was kind of cool. Anyway, this kind of suggests to us that we can get a linear transformation by multiplying a matrix times a vector. So let's look at an example of that. Let's look at a function t, which goes from R2 to R3, and t of v is equal to, so the function is equal to matrix A times v, and this here is the matrix A. So, for example, what would be t of 2, -1? So t is a function which takes a vector in R2, multiplies it by this matrix, and gets a resulting vector in R3. So, for example, if my R2 vector was 2, -1, then the R3 vector that it maps to is 6, 3, 0. Now, but we didn't really show that t is a linear transformation. We know it's a function, but how do we know it's a linear transformation? Well, actually, I want to prove that. Truth is, I'm going to prove something more general. I'm going to prove that anytime, so I really want to say that t of v, which is matrix A times vector v, A is an m by n matrix, is a linear transformation from Rn to Rm. And so for any matrix, any R's, so no matter what the dimensions of R is, and if any matrix, and that we really actually know enough to prove that, because A times U plus V is equal to AU plus AV, because we already established a long time ago that matrix multiplication is distributive in this way. Further, A times CU is equal to C times AU, and that's something we also established a long time ago. So we see in general, when I multiply if I have a function that's defined as a matrix times a vector, that is going to be a linear transformation from Rn to Rm, or from R wherever to R whatever. So what's going to happen is that we have an m by n matrix times an n by 1 vector, and that's going to give us an m by 1. My result is an m by 1. This is a whole long thing, but it just comes out to be one number, and that just comes out to be one number, even though it looks like a whole long thing. So it's an m by 1 column vector, and this is an n by 1 column vector. Anyway, this is a linear transformation. We really have proven it all a long time ago, and it all works. Yay!